by one. The first sequence is 2, 5, 9, 1. If we look at the difference between the 5 minus 2 equals 9. 5 equals 4. 40 minus 9 equals 5. Because the difference are constant, this difference is not arithmetic. It is also not geometric because the between the when is specific and the arithmetic one. Let's move to the second sequence. 2, 9, 15, 22, 30, and if we subtract consecutive term, 9, 7, 15 minus 9 equals 7, and since the difference is always 7, it's arithmetic sequence of 7. Finally, the third second is 3, 15, 74, 5, and so on. If we divide consecutive term, 15 divided by 3 equals 5. 5 divided by 15 equals 5, and so on, because the ratio is always 1. This is geometric sequence with a common ratio of 1. This effectively help us understand how to distinguish between arithmetic and answer. The slide show the correct answer from the previous activity. The first sequence is classified as neither arithmetic nor geometric because the different ratio are not constant. The second sequence is an arithmetic sequence because every time increased by 7. The third sequence is a geometric sequence because every term is multiplied by 5. When identifying sequence, it is important to arithmetic sequence focus on constant addition or subtraction, while geometric sequence focus on constant multiplication or division. By checking either the difference or the ratio, we can classify sequence correctly and avoid mistakes. Formula. After learning how to identify sequence, now let's study the formula used in arithmetic and geometric sequence. This formula is very useful because they help us calculate them quickly without predicting the entry sequence. First, we have arithmetic sequence formula. An equal to an minus 1 plus d. In this formula, an represents the term. A1 is the first term. D is the common difference. And n is the term number. Now, this formula is called the explicit formula because it always used to directly calculate an integer. Next, we have the geometric sequence formula. En equal to En minus 1 times R. This formula, if R represents the common ratio, this formula is also an explicit formula because we can directly find any time in the sequence. Besides explicit formula, we also use recursive formula. A recursive formula calculates a term using the previous term. Finally, we have some formula which are used to calculate the total of several terms in a sequence. This formula is very important in mathematics because they save time and simply calculation. Now, let's look at an example involving an arithmetic sequence. We are, we are given the fourth term is 32 and the common difference is 9. We are asked to find the sixth term because the term we need are first together. The answer towards the recursive method instead of the explicit formula. First, we find the first term. Since the common difference is 9, we add 9 to the fourth term. 20 plus 9 equals to 29. So the first term is 29. Next, we add 9 again to find the sixth term. For the sixth term is 311. 311. This example shows how recursive method works step by step using the previous term to find the next term. Recursive method are especially useful when the terms are used together and easy to calculate. Now, let's study another arithmetic sequence example using the explicit formula. The sequence is negative 7, negative 3, 1, 5, 9, and so on. In this problem, we are asked to find the 42nd term. First, we identify two common difference if we subtract consecutive terms. Negative 3 minus negative 7 equals 4. Negative 3 minus negative 1 minus negative 3 also equals 4, and 5 minus 1 equals 4. So the common difference is 4. Because the term number is very large, it will take too much time to calculate every term one by one. Therefore, using the explicit formula is the most efficient method. The arithmetic explicit formula is an equal to e1 plus n1 d. Now we substitute the known value. The first term is negative 7, the common difference is 4, and n equals 42. After substituting and simply we get a 42 equal to 157. So the 42nd the sequence is 157. Next, let's move to a geometric sequence. Example, using the recursive method in this problem. We know that the term the is moved to a geometric sequence. Example, using the recursive method in this problem. We know that in the term is negative 16 and the common here is negative 2. We know that the term is negative 16 and the common here is negative 2. We are asked to find the 12th term. Since the terms are closer together, we can use the recursive method by multiplying step by step. First, we calculate the 11th term. To do this, we multiply the term by the common ratio negative 16 multiplied by negative 2 equal positive 32. So the 11th term is 32. Next, we calculate the 12th term. We multiply 32 by negative 2. 32 multiplied by negative 2 equal negative 64. This example demonstration has important property of geometric sequence. Each term is obtained by multiplying the previous term by the common ratio. We can also observe that because the ratio is negative, the side of the term alternative between positive and negative. Now, to solve geometric sequence problem using the explicit formula. The sequence is negative 2, 6, negative 3, 17, 5, 4, negative, and so on. We are asked to find the sum term, but let's identify the common ratio. If we divide consecutive is negative 3. So the common ratio negative 3 because we need to find the term using the bit multiplication will be inefficient. Therefore, we use the geometric explicit formula. Now, En equal to En equation and next. Now let's move from sequence to series. Remember, a sequence is a list number, while a series is the sum of the numbers is a sequence. In this example, we are asked to find the sum of the first 40 terms of the sequence. 4, 9, 14, 19, 34, and so on. First, identify the common difference is decreased by 5. So the common difference is 5. Before calculating the sum, we first need to find the fifth term using the arithmetic sequence formula. After substituting the value, we find 45 equal to 2049. And so on. Then find the sum of the first 5 term is 6,575. And got this.